All right, good morning, Algebra 2 students. I hope you had a good weekend. Yesterday was a beautiful day. Hopefully you got out and you at least sat in the sun, if not walked around, moved around some. So today we're going to be looking at our do now. It's basically what we were doing before. So think about how you're going to factor the following expression. All right, so now that you've factored the expression, we know that the first thing we want to do is we want to do some simple factoring. So what number can we divide both these by? That's right, we can divide both by a 2. So we can factor out a 2. And can we factor out a variable? So we have t squared here, t to the 5th. So we can factor out the smallest number of t's, which is t squared. So we factor out a 2t squared. What's left over? Well, 2 divided by 2 is going to be 1. T to the 5th divided by t squared is t cubed. And then 686, can we divide that by 2? We're like, yep, we can. 6 divided by 2 is going to be 3. 8 divided by 2, 4. 6 divided by 2 is 3. So that number just splits in half. All right. And then we have no more t's because t squared divided by t squared is just going to be 0 t's. So t to the 0, which is the same as 1. All right, so now we have, I notice that I have a t cubed and it's 2 terms. So I'm thinking, oh, is this a special case? So I see a minus t cubed, 343. Is that a perfect cube as well? Well, let's check on our calculator. And I'm afraid I have the correct answer already there. So remember what I did. I'll just clear this because that's really what we want to do anyway. But just a reminder, math, number 4 cube root, and then 343. And as we already saw, it's 7. So 343, 7. So now I can write this as t cubed minus 7 cubed. And I want to make sure to put this part out front. This needs to stay with the whole part. This top expression is going to be equal to the bottom expression. It's just that the bottom ones are going to be factored. All right, so now what we need to do is can we remember what difference of cubes is? So if you don't have it memorized, write it right now because this will be helpful. So we know that if we have a cubed minus b cubed, what that's going to equal is, so now remember if it's minus, then it's you subtract a and b, so a minus b. And then the signs are going to go minus plus plus for difference. So we know it's always going to be a squared. And then with difference, it's always going to be plus plus. So again, if you don't have this memorized, make sure you memorize that along with sum of cubes and difference of squares. All right, so now, so in this case, a is t. And b is 7. So now we just put a t in for the a's. And we put a 7 in for the b's, and it's just straight up substitution. Notice I said 7, not negative 7. It's just 7, t and 7. All right, so let's write the 2t squared, and then we're going to write our first factor, which would be t minus 7. So notice that we get a real 0 here, and then next we have t squared plus 7 times t will be 7t, and then plus 7 squared, which is, that's right, 49. So this ends up being our fully factored answer. We can see that it's a quadratic in the second factor, the t squared plus 7t plus 49. But what numbers multiply together to equal 49 and add up to 7? And we're like, well, that doesn't exist. And this actually is going to give us some non-real zeros. So we get one real 0 and we get some non-real zeros. And then if we set this equal to 0, we would get 0. So that's how it would work if we were solving this one. But we're just factoring the expression completely right now. All right, so let's look at our agenda for today. So I'm going to talk about office hours, and I'm going to talk about our weekly schedule. So that'll be part of this as well. Notes on factoring 4 terms. We'll do some practice on factoring those 4 terms. We'll look at some homework. And our objective today, students will be able to factor and solve 4-term polynomials by factoring left side, right side. And this actually looks very familiar to us. So we're going to see that this is actually a process we already know how to do. It's going to be a matter of when we see 4 terms that we use left side, right side. And then we may have to do some other factoring afterwards or before. So that's going to be the tricky part. All right, so let's look at this office hours. So I figured a good weekly schedule for us would be Tuesday, we watch a video lesson, and then correct previous homework, and then you can start the new homework. So that's something you can do on Tuesday. Wednesday, I'm going to host Zoom office hours. So that'll be something that you can go at any time between 1 and 3. I'll be there. I'll either be, and then I'll talk about more specifically down there. And then the homework, again, we do that at 11:59. So notice that the assignments stretch 2 days. Watch a video lesson, correct homework, start homework, ask questions, and then homework is due at 11:59. Thursday is going to be the same as Tuesday. So watch video lesson, correct homework, start new homework, and then Friday, again, Zoom office hours. This one's going to be a little different, 12 to 2. So I did a survey, and people mostly had between 12 and 3. So I figured 1 to 3 on Wednesday and 12 to 2 on Friday. And then your homework is due at 11:59 p.m. And if you can't make either of these times, make sure that you're still asking questions via email, because I'll be checking that as well. Office hours, basically what's going to happen, re-engagement lessons. I'll be able to help you with homework, any questions that you have. And this part's important as well. School rules still apply, including these 2 things. Clothing, think about non-uniform day rules. And then for language, same as you're supposed to use in school. So we want to make sure that we're still getting as much done as we can, that we're not insulting people, that we're just, that our goal is to learn the math and to keep learning through this time. And then for your safety, I will record the meeting, and that I can explain more about that. So it's basically just so that for your safety, that the meeting is recorded. It's not something against you. It's just that it's so that somebody doesn't do something inappropriately, and then not that you would, but that somebody on my end would. So I'm obviously required to record the meeting. All right, so let's move on. So this next part we have, so now we're looking at 4 terms here. We got x cubed, minus 3x squared, minus 16x, plus 48. And we think about the factoring methods that we have. We have simple factoring, special cases, RS method, and left side, right side. And we're going to be talking about this one today, this left side, right side, and that's really if we have 4 terms. So if we look at the number of terms that we have, we know that simple factoring is for any amount, because we can factor any amount using simple factoring. Special cases, we've looked at when we have 2 terms. RS method, we know that works with 3 terms, and we're going to look at some more of those tomorrow. And then left side, right side, that's if we have 4 terms. So if we have 4 terms, we're going to try this left side, right side. Can we factor this left side? That's a terrible line. Let me redo that. I'm better than that. You should expect better than that. So x cubed minus 3x squared, so we can factor our left side. We can factor our right side. And then that's how we're going to be factoring this. So what can we factor out of this left side? And notice that this is something that we do in the RS method, but we can also use this to factor 4 terms. So we have x cubed minus 3x squared. Notice that we can factor out, that's right, x squared. So let's factor out x squared. And then we're left with, so x cubed divided by x squared is going to be x. Negative 3x squared divided by x squared, it'll be x to the 0, so the x's will cancel out, so we have minus 3. All right, and if it's minus in between, we write minus. So 16 and 48, it's like, whoa, what does that divide? So you're going to have to get your calculator, and you have to figure out, well, let's try to divide that 16 first, because we notice that in our left side, right side, this is a 1. So in order to get 16 to 1, we'd have to divide 16. So let's try that. So let's do 48, oops. Let's do 48 divided by 16. Some of you may already know this. All right, it's 3. So let's go back. We know that it's going to be 3. So we can write 16 is what we're factoring out. Notice that it's negative 16. So negative 16 divided by negative 16x is going to be x. Positive 48 divided by negative 16 is going to be a negative 3, as we just saw. So notice that we have x minus 3, x minus 3, so those are the same, so we can factor that out. So now we have x minus 3. And what's left over is this x squared minus 16. So that's going to be our other factor, x squared minus 16. So notice that we couldn't simple factor at the start. We ended up doing left side, right side because we have 4 terms. But now we have to look for special cases, and that's what makes this standard pretty difficult, is that we have to use all 4 of these sometimes. So let's look at special cases. Do we have a difference or sum of squares? Sum of squares isn't something that exists, but do we have a difference of squares? No. We see an x squared here, so do we have a difference of squares here? Is 16 a perfect square? Meaning, what's the square root of 16? What number times itself equals 16? That's right, it's 4. So this is also the same as x squared minus 4 squared. So let's do that. Let's factor this. So x minus 3, that's not going to factor anymore. But this we can write as x squared minus 4 squared. And we know that difference of squares, if you remember it, it is a squared minus b squared, and that's going to equal a minus b and a plus b. Remember, we figured this out because we multiplied these together and we got a squared minus b squared. So then that's why we know that this pattern works. So it's just going to be x minus 3, and then it's going to be, now it's a minus b, so x minus 4 and x plus 4. And these are our 3 factors. So this is factored completely now. We can no longer do any more factoring. The reason why the directions say completely is that someone may just factor it to here. But since this is still factorable, then it's not completely factored. So that's why we had to go all the way to this last step, because it said factor the expression completely. All right, let's look at another problem here. Oh, no more on this page. Let's go to the next one. All right, so we're going to do the same thing here, factor the expression completely. First thing we want to do, can we simple factor? So step 1 is really simple factor. So as you're thinking about that, what can you simple factor? That's right, we can simple factor a 2. All these are divisible by 2, and an x. Divide all these by an x. Notice there's an x in this last one as well. So let's factor out a 2x. And when we factor out a 2x, what are we left with? Well, we're left with x cubed. We're left with plus 7x squared. Negative 18 divided by negative 18x squared divided by 2x is going to be negative 9x. And then 126 divided by x, let's see here. So 12 divided, or 6 divided by the 2 will be a 3. 12 divided by the 2 will be 6, so 63. So let's write minus 63. And maybe your mind's already seen some patterns here of what is 7 and 9 and 63. All right, so now we have 4 terms here. So 4 terms, so that means that we're going to now, the second step of doing something that with 4 terms, so we simple factor, and then we figure out what factoring method is going to work. So now we just use factoring methods, or the rest of the factoring methods. And this one, we're really looking at left side, right side. So when we're factoring left side, right side, remember we want to see what can we factor out of this left side? What can we factor out of this right side? So what can we factor out of the left side? Well, let's see, x cubed, x squared, 7. So let's see here, we got a 2x out front. We can factor out an x squared. Now notice that this part here is going to confuse us a little bit, so we'll give it some space there. So we have x squared. And then now we are left with x plus 7. And then we have negative 9x minus 63. So what can we factor there? So let's try to factor out, we have a minus sign, so it's right minus if it's factorable. Let's try to factor out a minus 9. Okay, so negative 9x divided by negative 9 is positive x. Negative 63 divided by negative 9 is a positive 7. This last parentheses because of this first one. And then now we have this x plus 7, so let's factor that. So we have this 2x out front. Let's factor out that x plus 7. And then now we have x squared minus 9. So, and then our last step, step 3 to these, can we factor the two-term ones? So now we want to look for special cases. So what special cases do we have? Is x plus 7 a special case? We're like, no. How about this x squared minus 9? That's right. We know that this is the same as x squared minus 3 squared. And that is a difference of 2 squares, so difference of squares. So we still have this 2x. We still have x plus 7. Do I have more space underneath? I don't know. Let's check it out. Oh, I don't really have space. All right, so I'll just write it next to it. So I'll write equals here. So we still write the 2x. We still write x plus 7. X minus 3, x plus 3 for difference of squares. X minus 3 and x plus 3. And this is my factored expression, completely factored expression. And that would be my final answer. All right, so let's go on. Instead of doing this next one, what we're going to do is we're going to go on and we're going to solve some now. So let's factor and solve these expressions. So when we factor and solve, first thing, it's just like quadratics where we have to do our first step. What's the first step of factoring quadratics? That's right, our first step, step number 1, let's get a better one there. Step number 1 is to set equal to 0. Because notice that there's an equal sign here, so I know I have to solve it, but I need to set this whole thing equal to 0. So set equal to 0. So let's, what do we have to do? Well, let's put it, everything, keep it in order, largest degree, second largest. So let's write those ones, x cubed plus 2x squared. And then now we have an x here, so we have to subtract x to both sides. We have to subtract a 2 to both sides. So subtract x, subtract 2. Notice that it's x cubed, x squared, x, constant term, and then equals 0. So we set it equal to 0. Then our second step is to factor. And it's different for everything. So we need to factor now. Can we simple factor? And you're like, oh, no. How many terms do we have? That's right, we have 4 terms. So terms, question mark, we have 4. And if we have 4 terms, we're thinking left side, right side. So let's do that now. So what can we factor out of the first one? That's right, we can factor out an x squared. Then we're left with x cubed divided by x squared is x. 2x squared divided by x squared is a plus 2 minus, so we got to factor out a negative number. What can we factor out of negative x and negative 2? That's right, we can always factor out a 1 if possible. So this is actually a negative 1, so it's going to be x plus 2 equals 0. All right, so let's keep factoring. So we have x squared, or I'm sorry, we can factor out an x plus 2 because that's the same in both parts. And then we have an x squared minus 1. And then after we factor, remember, we want to do that third thing. Oh, I forgot to write equals 0. That third thing is do we have any special cases? All right, so do we have special cases? X plus 2, not a special case. X squared minus 1. That's right, this is also a special case. X squared minus 1 is x squared minus 1 squared. Remember, 1 squared equals 1. That's something that we kind of forget sometimes. So x squared minus 1, we can write that as, let me just move this part down a little bit here. So we have more space. We're going to need a little bit more space to complete this one. All right, so what was I getting at here? So now this is going to be x squared minus 1 squared, so we have x plus 2 And then now we have x squared minus 1 squared equals 0. All right. So that's going to be, that's right, x minus 1, x plus 1. So now we have x plus 2, x minus 1, and x plus 1. Notice we just wrote this in factor form. These are all x to the 1 for all of them. So now what we can do is we're like, oh, well, let's just set all these equal to 0. So x plus 2 equals 0. Oh, and then our fourth step, that's what we're doing right now, is we are solving. Solve for x. And we're going to solve for x. So x plus 2 equals 0. X minus 1 equals 0. And x plus 1 equals 0. So what does that mean? That means that we know that the sign switch, right? So subtract 2 to both sides. So we know that x equals a negative 2. And we put our set symbol. So the set is negative 2. We also know that it's going to be positive 1 and negative 1. So let's put them in order though, negative 1 and positive 1. So this is my solution. Notice that's factor and solve. So I need to factor it, and then I need to solve it. So, so that's factoring and solving. Remember, we also did just a factoring completely. So this is basically what we'll be doing. Here is your homework assignment. So practice 3, you have these 3 problems. It says factor the polynomial completely. So factor those completely. And then 4 and 5, 4 says find the solutions of the equation. And then number 5, oh, let me move the recorder here down a little bit. Okay, and then number 5, multiple choice. But what are you going to do? That's right, the same steps you did for number 4. You're going to, can you set it equal to 0 first? Then you're going to simple factor if you can. Then you're going to, after you simple factor, what can you do next? How many terms do you have? And then go from there. And then our last part here, we have a ticket out. So your ticket out, describe the steps of solving the polynomial. So it's basically like, what's step 1? What do you do for step 2? What do you do for step 3? What do you do for step 4? Try it without your notes and then go back and look at your notes. Or if it's probably just like 2 inches above where you're writing right now, I mean, you can just write those in, but writing them in again is going to be very helpful for you. The more we write it, the more we memorize it and know it. So again, let me just go back to what we have for our schedule here. So remember, today you're watching the video lesson, which is this. You're going to, well, today we didn't have homework, so you're not going to be correcting previous homework, but you're going to start the new homework. So start the homework, and then tomorrow from 1 to 3, Zoom office hours. That's that link that you can click in the assignment. And then, and again, that's from 1 to 3. And then your homework is due at midnight tomorrow night. I hope you all have a great day. I hope you're staying safe. Today's gonna be sunny again, so make sure you get some of those vitamin D sun rays. Have a great day. I hope you and your family are doing well. Bye.